Jo. A teďka? Jo, dobrý.
Tak já budu asi pokračovat rovnou. Test. Okay, so hello everyone. Welcome to the second day of vlog. My name is Nikola, this is Pavel.
Hey.
And we will have actually two talks in one. So let's start with mine. And we don't have a lot of time, so I will just...
Yeah, kind of lightning talking today, so enjoy.
Okay, so this is about SpecFile library. I don't know if you heard about it. If not, it is a Python library that's Python library for parsing and modifying spec files. The emphasis is on modification because that's why we designed it in Packet team. Also, it means that it's not very fast because like function over speed, basically. One of the main goals is that the changes that you make should result in a minimal diff. So if you edit someone else's spec file, the changes should be minimal. It's packaged for Fedora and Apple, and it is used by Packet and also, for example, Copper and some other projects. So from now on, I will be showing code samples. So this one should be pretty self-explanatory, I hope. Let me just talk about the bottom segment. Maybe you can see from the code itself, it should bump the release in the spec file and add a changelog entry. So basically, what RPM dev bump spec does. So the main tags are exposed as properties. So in this case, we are using expanded release, which is the value of the release tag with all macros expanded. This is a pretty naive example because it expects the result to be a number, but it's just for demonstration purposes. So the value is incremented and converted to string and written back to, or assigned back to release. And then there is a method for adding a changelog entry. In this case, we are specifying only the text of the entry, but you can also specify all other data like author or date, etc. Okay, let's move on. Okay, so in this case, we want to work with sections. This example should basically convert from changelog to auto changelog. So there is the sections method that returns a context manager, and in the target variable, it behaves as a list of sections, and within the context of the context manager, you can modify it, you can work with it as with list, and the changes will be propagated back once the context is exited. You can also access the sections by name, so in this case, changelog, and the section again behaves as a list of lines. So here we just copy the entire changelog and replace it with just one line that is auto changelog, and then we are just dumping the original content to the changelog file. So another example, in the previous one we were accessing the section by name. Now we are iterating over all sections, but this example should print just, or it should print all required stacks in a spec file. So we are interested only in package sections, skipping all else, and then we use text method that returns a list of text, or again a context manager that behaves as a list of text, and we just filter the required ones and print all the details. Okay, so that was pretty much it. There is, of course, a lot more, but I want to show you something more interesting, maybe. So if you have a spec file like this, and you want to update the version, and if the version is defined using macros, then if you just would just assign the version to the version property, it would end up like this. This would be the diff. And that's probably not what you want, or not what the maintainers want. So you can do this instead. There is this update tag method that tries to, if possible, it tries to actually replace the values of the macro definitions instead. The algorithm behind it is not very complex. It's actually quite simple. It just splits the string on some delimiters and then tries to match the individual parts to the macro definitions. So it doesn't work in all cases, but I would say it, well, I actually measured it, but I'm not sure about the exact number, but I think it was about over 90% of spec files that work, and it is possible to do this. If it wasn't possible, then the version would just be replaced as before. And this is my last slide. So I want to talk about macros and conditions. So spec file uses RPM for expanding macros and evaluating expressions in conditions. You can also define your own macros by passing them to the constructor, and you can expand any macro or expression using the expand method. And as for conditions, so in this case, you have two epoch tags. You would probably, if you would be modifying the spec file, you would probably want to change maybe all of them or both of them. But if you are only interested in the value of the one that would be the correct one, let's say, so that would be valid in case copy username is defined, then there is a valid property of the tag object, and that is true only in the true branch of the condition, or if there are nested conditions, it would be true only for the tags that are in true branches of all of them. Yeah, that's pretty much it. So I'm not sure if you have any questions. We have probably a couple of minutes, or I can pass it to Pavel, and then we can answer questions at the end. And there are some links, so I encourage you to check this, because, like I said, this was just a quick overview what the library can do, and that's all. Yes?
Question, will you repeat it or should I say
I guess you should say it on the microphone, but I'm not sure. Yes.
Thanks. I just wanted to ask, is there anything that the spec file library can't do right now? Like specifically, like tags it can't edit or limitations that you would like to highlight?
Not really. The only, well, not everything is like high level. So sometimes you have to do more work than it should be necessary, probably. But the only downside I'm aware of is if there are spec files where there are conditions that span across, or like, for example, there is else in the middle of a section, or because the parser is not counting with it, and there is open issue for that.
Okay. Thanks.
Hello, Pavel again. I'm engineer and RPM build system developer at Red Hat. And in this kind of lightning talk, I'd like to explain you what are my headaches with build systems and designing them, and especially source RPM or RPM build systems. A little bit of motivation. Anyone did before switch to root, download some weird script from the internet and pipe it to Bash to install some important software? Well, I did before, only if I really have to install something necessary for my day-to-day job, and the people decide not to package these things into Fedora, which really makes me like angry. But anyway, anyone generated a source RPM file from a spec file before using either RPM build or fed package source RPM or Taito source RPM? You should be aware that these things are similarly dangerous, except that you are not root, but still. But let me start with probably known things. Can anyone tell me what's wrong with this spec file? What can happen when I try to build it? Yeah. Exactly, yeah. There is this little typo, the dollar sign instead of a percent sign, meaning that I'm referring to a non-existing environment var. So I'm basically trying to remove var, which probably I cannot because I'm not a root. But if I was, I mean, how do you protect against these things? You probably don't run as root the builds, but you shouldn't do this under your normal user, like that one that you are using for Firefoxing and stuff like that and visiting your internet banking. Please don't. And you probably use mock. Maybe you don't. Mock tries to. I want to underline that on a best effort basis, isolate you from this kind of shooting yourself into foot. So here comes source RPMs. Can anyone tell me what can happen here when you try to build a source RPM from this spec file? I'm not going to blame you now. You cannot know that. You don't know that because you cannot, because you don't know what's inside that shell script over there. Actually, we need to evaluate that one to get the kvar macro content, to get the version, to actually place the version in the source RPM file name. Hence, I mean, even generating source RPM is not really safe always, depending what's inside that script. And you shouldn't probably like blindly trust the spec files out there. How do you protect against these failures? Mock source RPM doesn't help here. Of course, you need to get the source RPM first. So yeah, fortunately, there's a mock -- spec option, which is unfortunately not well known, but you are here, so you're lucky, you now know. And yeah, I wanted to point out that mock really tries on a best effort to isolate you. Some options are not yet well done, some are buggy. For example, this example option is still using RPM from host, meaning that it it suffers from these issues. But let me stop here. I am not here to talk about bugs in software that I maintain. So quick mention of Lua. Lua is Turing complete as well as the shell script, so it can cause the similar damage to your system if you build untrusted spec files. So how this all relates to build system headaches that I have? We basically want to let all of our users build whatever they prefer. The builds are done on virtual machines, so if they break it, they have the VM broken. We don't care, we just recyclate the machine and start a new one instead. But we want to allow them to build from GitHub or Fedora dist-git and basically cache the sources. I'll tell you why later. And then on each of the VMs, build one chroot according to users' wishes. Why we cache it? The reason is that we don't want to re-download the sources all the time from GitHub. We don't want to do distributive attacks to Pagure IO and stuff like that. And how do we cache? We basically run another dist-git. We call it a proxy dist-git in Fedora Copper. And we transform the sources from GitHub using source RPM files to this proxy dist-git. And did I say that I use source RPM files for this? So yeah, that's not really safe, and we need to be careful there while generating the source RPM files. And these things are not only about security. Some people do weird things, like they prefer using different tarballs when building on Fedora and different tarballs elsewhere. I don't know why, but yeah, these kind of things are not yet well solved in Copper at this point in time. If you are curious, take a look at this issue. So I was always asking myself whether we can replace this source RPM file, which is distribution and arch specific, with a tarball that is arch agnostic and distribution as well. And most of the time we could, but yeah, we have the sources file, for example, in dist-git, so which deterministically identifies all the sources that are, or at least can be used at RPM build time. So we could basically do git archive from Fedora dist-git and append, create a master tarball of this archive plus all those sources and use that for caching. But Fedora is not making our life easier. In this case, we invented a way to not provide changelogs at all in Fedora. Yeah, this RPM autospec thing basically means that the git archive is no longer enough, at least unless we want to lose the the generated changelog and the generated release field. Hence, we need to, first thing, we need to do full clones when generating source RPMs, which is not always a cheap operation. And we need to parse the spec file to get those things like version and release, to actually have the right values for generating the changelog. And for that, we need to call RPM parser, and that's not always safe, right? So another headache is this kind of exclusive arch. Build systems don't want to waste potentially expensive S390 VMs just to realize that they cannot be built because there is this exclusive arch thing. So we ideally want to parse the spec file in advance to realize that it doesn't make sense to evaluate or to start the S390 VM. Yeah. So how do you protect yourself, or how should we all protect ourselves? We should really be careful. Same way as we don't do, or at least don't prefer doing curl and pipe to bash, we shouldn't blindly build binary RPMs and not even source RPMs. And we should never build RPMs as root or some kind of privileged user IDs. So for real, what can we do about this in the future as the ecosystem? I talked about this with the clever and brave people maintaining RPM within Red Hat, and this issue was opened by Panu Matilainen as a result of the discussion. So we could basically have a new low privileged mode in RPM, not doing these kind of dangerous things like shell and Lua, maybe not doing includes, and that mode should basically ignore unknown spec file tags, those that are too new for that particular version of RPM. Right now, RPM, if it doesn't know the particular tag, it bombs and fails and it doesn't parse the spec file at all. Another option, maybe, here comes a little announcement of my Christmas 2024 project called, work in progress, no RPM. It's a non-Turing complete RPM macro processor, at least at this point in time. It's written in pure Python, so if you wanted to parse spec files on non-RPM distros, you have no RPM, you can use basically this one. It could be installed from PyPI if anyone packaged for it. And yeah, here comes a little example how that can work. You basically optionally can load all the macro definitions on your system using the system macro registry, and using that database expand a string that should have a spec file loaded. That's a spec file as a string. And then you can query the database or the registry of macros this way. To sum it up, if I can have a wish, please don't make our headaches worse, and keep your spec files as simple as possible. Ideally, at least the preamble section that defines the name, version, release, sources, patches, and stuff like that, because this kind of really matters. For example, that's one example of many, this kind of short commit references. These are using bash for no really good reason. You can use equivalent directly with some macro syntax. And if you could do this switch, please do, because that really matters. If we do this kind of switch to the new mode of RPM or to no RPM in build systems, the variant below will be parsable, the above no. Okay, that's about it. Any questions?
So if I use the no RPM library, how big of a chance is it will work for my spec file?
It depends what exactly you want to read. I tested it on the version release, basically those things that we need to make RPM autospec happy to successfully generate the changelogs and releases, and it was like, I tested it on all those rawhide spec files. It's like 24,000 of spec files, and only like 300 of them did not give me the same value for release and version. So it's pretty good. But if you wanted to parse other things, there is a huge to-do list in the no RPM library that needs to be implemented to provide better results.
So what about dynamic build requires, like being able to evaluate build requires and put down a list to identify what a build environment needs to be created with ahead of time?
Of course not.
Yeah.
You probably know. For dynamic build requires, you need to extract the tarball and run some scripts that are fully in control of upstream, basically. So we don't want to evaluate ideally anything to get the version of the software from spec file. So no.
Is the no RPM packaged?
It is not yet. As I said, it's just the Christmas idea of this year, so going to make it Fedora soon.
So if I want to protect myself the best, how should I build random unknown specs downloaded from the internet? Should I do it in a container or something?
Submit it to Copper. There are VMs that we dispose. If you get it broken, nobody cares. Or, I mean, you should really review the spec file first. In theory, mock protects you, but it's on a best effort basis. So if you use the mock -- spec and you give it the spec file, it is most probably okay. But if the person tries really hard to escape from a mock, he would be probably successful.
So, question for both of you. So, how is the spec file package like different from the no RPM?
Okay, so that's probably on me. Spec file uses RPM for macro expansion and condition evaluation. There is actually an open issue for about not doing this and implementing something like no RPM inside the spec file library, but it's just there is no plan yet. It wouldn't be so easy. I mean, well, I guess it would be, as Pavel said, maybe the basic stuff could be possible in a short time, but definitely not all the complexities that RPM is capable of.
Yeah, the spec file is really widely used nowadays. Like we use that library for every single build in Copper, so it probably parses everything you need. But it uses RPM in the background, so you should know that if the spec file is dangerous, then you face potential problems.
Any other question? Okay, so thanks for your attention and enjoy the rest of Flock.
Sound? Oh, no sound. how's this font size? Is that too small? Is it okay? Make it bigger if you want. All right, I think I'll get started. Welcome to this talk about tools. My name is Jens Petersen. Yeah, I think that tooling is really important, and yeah, maybe it's not one of our biggest strengths in Fedora, but so I spent some of my copious spare time writing some tools. I thought I'd talk about some of them today. Yeah, so actually there are quite a few, maybe it's a bit ambitious, but I listed quite a few here. But yeah, mainly I wanted to talk about fbranch a bit and some of the other tools like DL Fedora, DL DNF repo. But yeah, maybe I'll just start with this Fedora CLI tool. It's a bit of reverb. It's kind of surprising. We don't actually. This is actually the only, I think, CLI tool for querying Fedora. We have in Fedora. It's packaged in Fedora. So yeah, this defaults to using the dist-git Fedora. So you can use this as a simple tool to like list packages. It supports globbing and so on. So I think I had some examples I did up here. Yeah, you can also count the number of packages, which I kind of like sometimes to. So you can see there's about 3,700 Rust packages in Fedora now, 3,100 plus Python packages and so on. Yeah, but you can also actually, yeah, you can also do things like list groups. You can also list packages by user or by groups, so you can list all the packages for a SIG or something like that. Well, the actual listing functionality is already integrated into fbranch, so yeah, you don't actually need to use. So if you use Pagura list, it will actually prefix the packages with this RPM's namespace, which is kind of annoying sometimes. Whereas if you use, sorry, it's a very long list. To choose one to show them here. So if you use fbranch, it doesn't prefix them with RPM. So anyway, yeah, that's probably enough on that. So let me talk a bit more about fbranch. So fbranch started off as a very simple idea. There's a lot of repetitive work in packaging. So you have a new version of a package you want to update to, then you have to update your spec file, obviously, and commit the changes, add the sources, and then push your commits and start your build, and then it'll get pushed to Bodhi. Then you also have to do it again. Say you want to update all the branches like 42 and 41 and Apple and so on, then it's a very repetitive process. So the initial idea of fbranch was just to have a way to kind of semi-automate the process to make it more reliable. So, yeah. So you still sort of keep the human in the loop, so it's not sort of completely blindly running. Yeah, so I just yesterday released fbranch 1.7 and built it for Rawhide. I think, yeah, so let's see. So maybe we can build it for F42, since I only built it for rawhide. So have a command here. And there's a couple of dependencies which are also needed, which are also being updated at the same time. So this is a parallel build with these two libraries, and they'll be automatically be sorted into dependency order. So and this -s means that it's using a side branch. In this case, it's sort of manually prompting me to merge the changes into the F42 branches. It's not terribly clear, but hopefully it will start now. Okay. So so this is now pushing the builds to Koji, and it'll build the two libraries in parallel, and then wait for those to be in the build route before building the F-branch package. So, okay. Go back to the slides. I think F-branch is particularly useful for packages. We have very large package sets. So it supports not only building across branches, but also sort of iterating over many packages too. So, just checking time. Okay, and there's actually a lot of commands, so I don't obviously have time to talk about all of those today. But you can ask questions. Maybe I'll continue, and we can return. More detail if there's time later. Also, if you have questions, do just raise your hand, and I can take short questions during the talk. What's new in 1.7? Well, actually, the biggest thing is now it supports Apple minor branches like Apple 10.0. Also, now merges are done from origin, which was previously not the case. So previously you could merge in unpushed commits from a newer branch. I decided to enforce this to make things more consistent. Another nice new feature is that if you have multiple side tags for a branch, now using the side tag option will now prompt you to choose which one you want to use. If there are already existing open side tags. There's also a new experimental mock install option, which will allow you to install packages that you've built via mock locally. Another nice feature, I think, is this request branches command now also. F-branch tries to check lots of things before doing things that might fail. So in this case, it checks if you have permission to make a branch or to request or to have a branch made for you. And previously, it only did that as a sort of user query, so it would check if you have the commit access. But now it also checks if you have access via a group, like a SIG or something like that. There's a few. Another recent feature is that when you request branches, it now also waits for the package to be available in Koji, so that you won't get a build failure if you try to build it too quickly. So if you're requesting branches for many packages, it will now do all the requests first and then check the Koji afterwards to save time. I've changed the default review package mode to this sort of streamlined interactive mode now, which I quite like. There's also an uninstall command. And yeah, someone complained that crates were not recognized as archives, so that's now fixed. Another good feature, although it only works for a couple of weeks per year, is that it now checks for OAL of branches approaching. So if you're like less than a week away from OAL, it will warn you not to build that branch. Yeah, this was the previous release. Had support for local builds from detached head, which I think is something that Fed package can't do. There's also an auto-spec command which might surprise people, but yeah, this is occasionally useful if you have some package that for some special reason you want to auto-spec. Anyway, I've used it a few of mine. Yeah, there's a few other things here that I might skip. Yeah, I mean, last year the 1.5 release was quite a big thing because due to the change from PDC to Bodhi for released metadata. So yeah, and that release also introduced the use of sort of chain build style args with colons between different dependency layers. So that's also supported and also requested by several people. Okay. Let's just see how our build is going. Okay, they're still building. All right. And under the hood, FBranch also uses this RPM build order tool, which is also a library. Which is what it actually uses to order dependencies. It's not quite perfect, though it works fairly well. I think the biggest deficiency may be around CMake dependencies, and build dependencies. Yeah. Yes?
Does it handle also dynamic dependencies? So dependencies that are not declared in spec files but are calculated?
Yes, it does, yeah. It generates these BR SRPM files and then yeah, but it's not perfect. I mean, so maybe I should add a bit more about, so this RPM build order and also FBranch, when it's trying to do dependency ordering, it doesn't use any repo queries. It's just trying to use the raw sources in your package, like your spec files and so on. So the idea being that, well, potentially the repo queries might be out of date in the sense there may be dependency changes, though, yeah, obviously in many cases that wouldn't be the case, so I could maybe have an option to defer to repo query, but also repo query is not particularly fast, so if you have like hundreds or thousands of packages, then it's great. Yeah, but yeah, so RPM build order uses directed graphs to do that. And there's a few libraries that are being used. So one is this Fedora releases library, which I think I briefly mentioned. So it's also being used by DL Fedora and what else? I think I've written it here, yeah. Fedora repo query. Some bad markup here, but so yeah. So actually, the Apple 10.0 support is actually mainly here, but anyway. Then this select RPMs is kind of interesting, and it's also used by the Koji tool install command. This lets you select which kind of sub-packages you want to install. So if you do, maybe I could, let's see. So yeah, nearly all the FBranch commands have their own help. I mean, they all have their own help. So here, for example, you can use globbing here too, so you can specify which sub-packages to include or exclude. Actually from here, but anyway. For some packages where you don't want to install the devel sub-package, or you don't want to install, I don't know, some other subset of packages, you can control that easily. Not sure how time is going. Okay. Okay, maybe I'll move on. This DNF repo, which I find quite useful. I'm not sure many people are aware of it. This basically allows you to control which repos are enabled for a particular DNF invocation. So, I don't know, I have quite a few copper repos, say, and maybe I turn them off by default, and then I only update them sort of periodically, so it just saves some time. Yeah, you can use it with any DNF command, obviously. So it's just a wrapper. Also, it also avoids having to write sudo, so it's sort of anyway, I find it a bit quicker. And it does pattern matching on repo, so you don't need to type out the full repo. You can just type out a few letters of substring of the repo name to enable it. So yeah, by default it just lists all the enabled. So in this case I seem to have the VS Code repo and Rawhide enabled, and there's a bunch of copper repos and stuff. So for example, one could just enable all the copper repos like this. In this case it just tells you what it's going to do, and then if you do something like this it will start. Anyway, I'm not going to do that now, but anyway. Conversely, you can also disable repos, so you can, if you want, so say you had all the copper repos enabled, you could then say, I don't want to use any copper repos in this DNF command, and so on. Okay. Right, then there's Koji tool, which, I don't know, I use this quite a bit. The two most novel things are there's this progress command which lets you I'll just make it a bit bigger. Let's see if anything's built in Koji. Okay, there's some things built in Koji. I'm not sure what this is, but let's see if we can. This just tracks an ongoing build, and it just looks at the size of the build log files. So for longer builds, sometimes it's so nice to see how builds are progressing. But yeah, I think the Koji install command Koji tool install command is quite useful. Yes. Right.
Or the other. Do you have a tool or an option maybe for people that just tails like a tail -f for the Koji logs?
Not exactly, no. I think I've thought of it, but
right now we have to go to the browser,
right, yeah,
go to the watch logs option in the task, and having something like that in the console terminal would be nice.
Yeah, true. I can't do it exactly, I think.
Similar to the main coding tool, just watch task.
Right, yeah, I get your idea. Yeah, it's not a bad idea, I think. I think it could be done. Well, but it's not, yeah, but it's not, yeah, that's the thing. So you can get it. Right, yeah. And I also use this in fbranch. If there's a failure, it'll print out the tail of the build log or the root log if it determines that it's probably the root log. Yeah. Sure. I guess I could very quickly do, since I built this yesterday in Rawhide, I can actually install the... Okay, so now it's actually asking me if I want to install all these. Well, it's offering to update all these packages, but so if I only want to, how do I do that? Oops, sorry. I'm too nervous. I can maybe exclude yeah, so now it offers only to update the, there are some sub-packages in there. But anyway, so it's, yeah, downloading directly from Koji, since I think the Rawhide compose may not be out yet, or at least. So we can check. Yeah, it's still running. Okay. Yeah, there's also this find command, which is kind of cute. It allows you to write things like find my last fail or something like that. So it'll find the last. Yeah, I mean, it's a bit limited what it can do, but it has some different keywords. Yeah. Anyway, sometimes it's a fast way to get something. Yeah, maybe a little bit about DL Fedora. I have a few minutes left, I guess. So, this tool is for downloading ISO images. Yeah, so, okay. So yeah, it supports quite a few. Most of the additions and spins and whatnot, and also respins. It even has support for CentOS Stream Live images and ELN and stuff. So yeah, you can also run ISOs that you've downloaded with QEMU. Yeah, one good thing is in the last version now, it now stages the downloads in a sort of a subdirectory, because I don't know, I often find I start downloading something and then maybe it's too slow, and I just get abort the download, but then it would leave a partial download in the main download directory, which is kind of not nice. So yeah, so. And one thing is that the naming of the ISO files is quite somewhat random, or I don't know. Also the move to Kiwi and so on. So it's a bit of an effort to sometimes keep up with all these changes, but try to do that. Yeah. Anyway, yeah. There's also a Fedora repo query, but I probably won't talk about it now. Since I'm not running out of time on a few other things. This tool, if you're using RPMOS tree, I find this really useful. It's a very simple thing. It just pins a currently deployed current deployment. So yeah, so if if you want to kind of preserve that. Well, I guess I can, since I've finished my talk now, I could do it. So yeah, I have a few. So currently this one is pinned here, as you can see, but I'm actually running this one, so I can do, oops, registry pin. It asks me for my password since it needs root. And now this current deployment is pinned. I mean, that's all it does basically, so it's very simple, but it's a bit tedious to write all the commands, so yeah. And yeah, this is also quite nice. This is just a little tool for querying Bugzilla. It just generates a URL based on some keywords. Yeah, I think I'm out of time. So there's also df simple. I prefer the, I don't know, I find the default df output quite difficult to parse. So yeah, sorry. Just provides a rather more concise, it more or less provides the same info, but in just 4 lines, so yeah. Sorry, it's a bit small. Anyway, okay, maybe there's a few minutes for questions if anyone has any. Well, I can relay the question.
Yeah, so some of these tools seem they just augment like other tools, kind of.
Right.
Did you start at just, oh, this is just for me type of thing, just useful for me, and then like it got adoption, or did you originally try to upstream some of these things and that didn't work?
Right.
I'm just wondering if like it wouldn't make sense to put some of these
Sure.
features in the like official CLI tools.
No, you're right, yeah. Indeed, it's true. I would be better, I agree. I mean, one problem is language, so yeah. I mean, so the sort of elephant in the room, these are all written in Haskell, so it's a bit of a, yeah, that's one thing. So firstly, I'm very happy for people to steal any features and re-implement them, or to, yeah, I don't really do heavy sort of deep Python myself, so it's one limitation. You're right. I don't know, I feel like Fed package has also improved a bit lately. I don't know whether it's at all influenced by, but yeah, I also think of F branches as kind of a testing ground for future possible features. But no, you're not wrong. I agree. Yeah. It would be good to. No. Yeah, no, it's a good question. Yeah, right on it. There's also, yeah, I should also mention there's also Fed RQ, another repo query. Yeah, I didn't really talk much about Fedora repo query, but yeah. Any other questions? Okay.
Does Packer CLI, can it show you which for a package who are the maintainers?
Oh, that's a good question. Thanks. Yes. Let's see. Oh dear. Sorry. It's a project. No, sorry. Let me do it over here. Sorry. Oh dear. What is going on? Yeah. So it's not super friendly, but yeah, it sort of basically does the YAML version of the JSON. So this is Bash, for example. So you can see the, well, I guess the main version is here and so on. Yeah. Stuff like that. So yeah. All right. Thank you very much. Thanks for watching.
much there.
Is there?
I mean, inside.
Let's see.
Did you just see like my background? Is that what you see?
No, I don't see anything. It was just dark. Let me see. Can we try another? Let's not see. Let me try the other one.
Sorry, guys. Well, we don't have a lot of time, so he's gonna try to figure it out, and I'm just gonna kind of start. We'll see how it goes. So, first of all, howdy. My name is Sean Trocchio. I am a software engineer at a company called HEB. I have been a software engineer for about 15 years. If you would not find me online or helping out, then I will be scuba diving. So if you're interested in that, please come talk to me. I have a father of 3. My first time at Flock, so thank you all for having me. It's been actually a very memorable and very welcoming experience. I appreciate everybody. He removed it. And we're here to talk about bootable containers today. You guys have heard a lot about what bootable containers in Timothy's talk and Dusty's talk and stuff, and I'm here to kind of talk to you not about the conceptual aspect of it, about what we could do and where we can be, but where we're at today and my actual implementations of bootable container systems. Any look?
I don't see it. It just doesn't recognize the...
Yeah, like email it to you?
Yeah,
Or
I can. Oh, definitely. Yeah.
Or a USB drive or something?
Yeah, I'll bring one.
All right, so anyways, so bootable containers, what does that mean for us? It means that our whole entire OS is defined in a container file, right? It means it uses the OCI image format. It means that all our upgrades are atomic. They're atomic units, so that way you can treat your, that works, cool. Cool. Cool, there you go.
Thank you.
Thank you.
So I'll take it.
Yeah. All right, well, he goes through that. So atomic units, meaning that you can treat your computer knowing that it's going to boot up that next time, because no more failed upgrades, no more bad packaging. It means when I go from one update to another, whether that's a minor version or minor to major or major to major, it's all an atomic unit. It's all either going to roll forward or roll back. And this combined with the very interesting security aspect means you can have a full end-to-end signed and verifiable secure system between something like UKI boot, between your signed container images and between OS Verity and the read-only file system in Compose.fs that will be coming. Here we go, cool. That's me, scuba diving. All right, so I just talked about all that slide. I want to highlight something here. There's a lot of icons up here. Because bootable containers are just containers, it means that we can use all of the existing technologies that are already in place for containers, but on our OS. And that's a really powerful paradigm. These aren't even all the things. These are just the things that I personally use on my bootable containers. So this is my hard-won knowledge. These are all my adventures that we've gone through. So first of all, I have a lot of QR codes. These is because I bought the receipts, and I want to make sure that everyone is able to quickly get to that, whether, because you're not going to have the link if I just put it here, right? So everyone, please look at it, and if you're online, you should look at it too. I'll make sure I give people proper credit for what they've done. This was a blog post by Mr. Ryan Daniels. He wrote about his experiences installing bootable containers and things that didn't work. The first thing that he found is that RPMs don't always install nicely here. I'm gonna bring my container notes for my thing here. All right. So if you are trying to in your RPM package, trying to add a user or a group or looking for a certain UID or GID you expect to be there, it might not be there. This is due to UID and GID drift that can occur between two different images. Even though you built it the same way using the same container file, the IDs might drift. So in order to mitigate this, we recommend you use systemd dynamic users, because then they're automatically provisioned on every time the image loads, and you don't have to worry about UID or GID drift as part of your systemd units. The next thing you might happen if you're writing to /var as part of your RPMs, that will not work. Any kind of script that you have is just gonna fail when you do the RPM build process. Sorry, when you install an RPM through the build process. I recommend instead that you copy the files that you need to go into /var as part of the image build process. So keep them as part of your repo and then manually just copy them in your container file. The next thing, systemd does not come up when you do your build image process. Therefore, if you are trying to look for something or rely on something in systemd, it will not work. Important gotchas. All right, the next thing. Yes, the Etsy safety dance. Etsy gets treated a little differently and has some gotchas you should be aware about. Number one is that the Etsy hostname file in the build time is ephemeral. It's actually a bind mount from whatever you're running this on, and that prevents the file from getting persisted. Well, actually, it prevents it from being changed, and it does get persisted into your actual container image, which can be a problem if you're trying to define your host name as part of your day zero operation of deploying your image. There are a couple ways around this. Number one is to use a builder pattern where you have a multi-stage build, and then you can write your file in the builder, and then you can just copy it in from the builder as part of your next stage. That will get around that problem. You can also run the no hostname flag as part of your Podman or Docker build, and then that will prevent the hostname file from ever being written, and then you can write in whatever you want and it should persist into your image. The next thing, RPM packages, scripts, batch scripts, whatever you're gonna run as part of your build image process are gonna look for may look for certain files like Etsy local time, Etsy time zone, and those don't exist during the build image process. So if you're doing anything that looks to that, it's gonna fail. Finally, there is a well-documented three-way merge. That's what this QR code here is for. I highly recommend you look at it. It dictates that local files will get the preference. This means that if you have a file that is already in your file system that you have created, and then you say, I like that, I'm gonna add that to my container image. And then you make a container image, you publish it somewhere, and then you do a bootsy update, you're not gonna get that update because a local file that you wrote that first time has preference, meaning anything I do ever in my CI/CD pipelines, whatever, down the road, or any upgrades that are part of my image, will not get affected on that system. That's an important note because it means you really have to use one pattern. You have to either do everything locally and use your local files, or you have to use everything in CI/CD and resist the urge to change things locally. There are ways around that. There are like transient tempfs stuff you can do to kind of play with it without overwriting what you already have, but it is an important gotcha that has bit people many times. Yeah, my personal opinion, we are not ready for a local-only usage of bootable containers. This is a link to something that helps. It's a tool called DNF Boot C by Eric Curden. But right now, if you try to just do local builds only, not trying to do bootable containers in a CI/CD pipeline, it's very slow. It's a slow process, and it takes a lot of space because you have to build your image. First, you have to pull the image, whatever your base image is you're getting, bring that into local storage. Then you have to do the OS build, or the bootable container build. And then you have to import that OCI artifact onto the OS tree storage currently. That only takes a lot of time and duplicates the space, and we're talking gigs here, right? That's how big these images are. So it takes up a lot of space, potentially on a storage hampered system. This will be solved, though, when we have ComposeFS, because then it will be a unified storage, and we won't have to have this duplication of our OCI images. Oh my gosh, guys. Bootable containers are amazing for major upgrades. I've never had to worry about I did two. I did 40 to 41 and then 41 to 42, and I didn't have to worry about it at all. There's an article here by Mr. Guitar, a man named Ben, who talks about his experience on his personal experience using bootable containers and how he did his major upgrades. The long story short of it is I recommend that you use, just like Dusty said, tags and streams to make sure that you're doling out your changes slowly across the appropriate systems rather than an all-at-once kind of method. And this is why I think Universal Blue did something really right. They have a very flexible system where they're able to, as the free release builds of like the next major version come out, they will start building them themselves as part of the CI/CD process. They'll add a tag for testing, and then it's really easy just to switch tags on whatever branch you're trying to test off of and use. And so they'll have a couple weeks where they'll let testers or any user just kind of go that testing branch, try Fedora 42 or try whatever next major version is, report any bugs out, they'll fix them all up, and then by the time 40, 42 or the next major version is released, it's good to go. They've ironed out all the kinks. And because of how flexible tags are as toward an image, you can make it as easy as you want. They have a latest if you want the bleeding edge. They have 41 if you're dedicated to just having 41. They have a 42 if you just want that major version. They have the long-term support model, which is always like the latest -1. Whatever experience you want to give to your customers, your clients, your partners, you can do that. And I really think that's a great thing. But the problem is not everything installs super well. NVIDIA is still a major pain in our butt, as we all know, and things like ZFS support or whatever extra thing you might need to install, not always super easy, but still doable. Oh, they're not changing. I'm sorry. That's awful. I'm sorry. That is the Mr. Guitar's blog post, if you want that. I'm sorry about that. Thank you for calling that out. All right. Testing. Testing is hard, guys. I went too far, sorry. Testing is hard. Testing container is really easy, actually, because you usually have a very small scope. It's usually like just your application, and you can look for, my files are there, my thing behaves the way I expect, I pulled down this thing and it's there. Awesome, no problem. Testing bootable containers, though, is much more complex. You're not just testing, I have my one application in my container. You're testing a whole bunch of services are all there. And because of what I stated earlier, where things like systemd aren't present during the image build process, you can't just, in your CI/CD process, say, great, spin up my image and let's test against it, because not everything is there. So in order to do this, you really have to spin up like a whole VM dedicated to this as part of like your CI/CD process. This is an article by, or actually it's a PR. It's a PR by Martin Pitt from the Cockpit Project. He wrote a PR about actually taking a bootc image, spinning up using QAMU in a GitHub Actions pipeline, I think, and then testing against it there. And it's a start, but it's tough. Yeah, so what I'm gonna, it's not easy, yeah.
It will get easy. Join our local network. Thank you.
Perfect, yeah, there are ways to do it. We just don't have it right now, but it's gonna scale out better. And yes, testing farm might help with that. I'm very excited to learn more about that.
Why can't you test system D inside of a container?
Because whenever you run your image, as part of a CI/CD process, you're spinning it up as a container image, right? You're spinning it up using Podman, and not all your things are there. Like I said earlier, you're missing files like etc host name, etc local time. System D is not up during that time because it's using. Yeah, you're right. You're right. But not everything is there. That's what I'm trying to just illustrate. That there are just differences between running a bootable container as an image versus running it as a VM.
No, I understand it. I wrote Podman. So, I mean, the bottom line is you should be able to test all the user space as a container before you actually install it on the system.
Hopefully. That's the goal. Okay, we'll talk more about that. Because we're running out of time here. So next thing, what I recommend is if you do want to test your pods or your images, I recommend adding a separate stage where you just add on the extra layers that you need onto the layer you're trying to test. And that will allow you to make sure you have things like PyTest or Ansible or whatever else you need to run your tests versus having that cruft in your actual image itself. This has proven to work out for me pretty well. All right. Yes, how far can we go with bootable containers? I think we've already kind of proven that a server is definitely within reach. Developer workstations, absolutely within reach. I mean, that's the whole entire thing like the universal Bluefin DX does, right? Absolutely within reach. I've been using it now for years, or 2 years. Awesome. Kubernetes hosts, can you use this as like a Kubernetes like agent node or master node? You absolutely can. You absolutely can. Not a problem. I've even done it using system extensions, system D extensions, as well as just baking K3s into my image using the scripts that they provide. Not a problem. Can you make it a NAS? Yes, you can. You can make it a NAS. You can have your etcfs tab be part of your repo. You can install ZFS. I've got NFS and Samba both working as part of a bootable container. That gets you pretty far. That's pretty good. Add Cockpit on top of that. You're set. That's going to be a good setup. A hypervisor. Ooh, this was my goal. I wanted to know how far could we push bootable container technology? What's ready today? And I said, what's the most complicated thing I can think of? And I came up with an OpenStack hypervisor. I was at Rackspace for a long time, and that was like the bread and butter, right? That was the thing that we ever wanted. So I tried to make an OpenStack hypervisor. Can you make one? No, you can't. It's really, really tough, guys. OpenStack is really complex, and the only way to really deploy it is using tools like Koala, and OOO and stuff. And these are scripts that run, and just because how bootable containers, image process, build the image process, not everything is there, it's missing files, it just doesn't play right. And I didn't have the time to go and start debugging everything. So too many cuts, couldn't make an OpenStack hypervisor, but in KVM one, sure. That could work. All right, some of my thoughts. I really like Dusty's image from yesterday of how there's a spectrum from bring it yourself, do your own, to consume from a deliverable somehow. It's a spectrum and there's a lot of overlap. So things like Cloud Init, Kickstart, Ignition, and like bootc have a lot of overlap. You can do a lot of things as day one, day zero, and day two operations, and there's not really a good rule for like where to put things. It's all up to what you want, which is both a blessing and a curse, because it means we have containerization technology that's flexible and allows you to make what you need but also it's kind of difficult to get started if you don't know really what you're doing, you don't have good fundamental practices. And then again, like I've said, local usage, not there yet. We're going to get there. But there's a need out there in the community where people want to just do this locally only. They don't want to have to spin up their own CI/CD pipeline. They don't want to spin up or have to use a tool like Koza to get all the things they want. They just want it to boot and then for it to run and just be atomic and have all the benefits. That's embarrassing. All right. Let's see, which one's that one? Tips and tricks? Yes, tips and tricks. All right. So tips and tricks. These are my recommendations for if you want to get started. What should you be aware of? I would say learn how to write container files effectively. There's a lot of caching that can happen between the different layers of an OCI image, and I want to make sure that you guys are caching as much of that as possible. This QR code here is my example repo that I have with a bunch of different bootable container images and CI/CD and all that stuff. You're free to copy and take that. It also has like bootc image builder built in, so you can just say, you know, what stage you want and just hit go, and you'll just get an ISO artifact out of it. It also has, oh my gosh, it has, this was a cool one. I use Sift to create an SBOM of my container images. So it's not just my application, but my whole entire OS. And then I was able to use Gripe to do vulnerability scanning against all those. And then I was able to upload that to GitHub Security Center. And that means whenever one of my container images gets built, which is weekly, I get a set of new alerts for every single image saying, here are the vulnerabilities for these things at this time, where it came from, and it tells me the CVE number and everything, and gives it a score. And that's a kind of like visibility for a whole entire operating system that's not so easily achieved today as part of just a CI/CD system update. That's really powerful. So that brings me to my next point. Use all the existing technologies. Anything that's out there for container, you can use for your OS. Like I said, use tags and streams, make sure that you're doling things out. A good example I heard yesterday was like a university who wants to roll a change out, right? Maybe you start with a change in, a computer lab, right? Test it out there, make sure it works, then you can dole it out to your library, they can dole it out, right? Use tags and streams for the best flexible experience that your customers, your clients, you are looking for. And then a personal recommendation is, I have a lot of different types of hosts. I have like K3s master, I have K3s node, I have my NAS. Switch it up. Use different container files and then bring in your image, your base image there, or have different stages for each different type of host that you're trying to do. So with that said, I think that's it for questions. Thank you guys. Yes? Oh wait, do you want a microphone? Are we doing that anymore? Is this on?
So how close are you to have the systems bootable from network devices?
From network devices?
Like with iBixi or Bixi boot?
Oh yeah, you can do it already, because that's just a disk image that you're putting onto Pixie boot, right? That's just a disk image. Okay. So if you get a bootable container, you can use, there's I think 3 different ways right now to create that into a disk image. And then you just put that onto whatever system you want to boot from, and that's it. So I did that for like netboot XYZ. I just took a base image, put it in there, all my things netboot from it, and then I can switch to whatever image, right, I want.
Okay, and in this case, which init RD you are going to pass to the iBixi? Any one or the one that I have within the boot C?
It depends how you want to go about it. You can do one per, if you want to have like 5 ISOs, right, then you can totally do that, and you can boot off that, or QCal2, whatever you need. Or you can just have one base one, and then you can have like Ansible or something go in and switch out to whatever image you want to look at.
Thank you.
Yeah.
Are you aware of any clouds out there integrating OCI images directly, like in a way that I would build a golden image using Podman build, pushed that to a registry and told the cloud, hey, please start a VM from this image?
Yeah, I know what you're talking about. I'm not aware, But again, I don't work at any of these vendors. I'm very much a community member. I don't work for Red Hat, so I wouldn't know. But if you want to use like OS builds, Bootsy Image Builder, to create AMI, to create, what is it, GVE, GK, the Google version of it, right? Azure one, you can totally do that, upload them, not a problem. But no, I don't know of anybody doing it.
Another question maybe, is the OS3 thing a mandatory thing for these bootable containers? Can't I have a normal golden image without OS3 thing?
Without OS3?
Mm-hmm. Is there some technological requirement between these two?
Between OS3 and bootable containers? Yes. So currently the bootable container base image, like the one for Fedora, comes with OS3 in it. That'll get replaced by ComposeFS eventually, and then that will be the default and what everyone will use. But right now, yeah, there's a dependency on that.
Thank you.
Questions? This man seems important back here.
Have you done anything with Podman Bootsy?
Podman Bootsy?
Yeah.
Absolutely. Yeah. I don't want to tell everybody, like, here's the secret, but yeah, if you just use, like, Podman Desktop to create a Podman machine and then use that, it's a really, really streamlined process. Yeah. Right on time, guys. Thank you for your time.
Klídek. Čekaj, ještě nabíjačku, nebudem potřebovat, kolik máme pak. 72% baterie to mohlo vydržet. Je to tam, alebo nejdete? Hej, zobud se. TF. Co to je? Už to fungovalo. Is everything connected? Because like the sharing doesn't work for me. Like any idea? Is it connected? What the hell? Je to není kábel, alebo není?
You have to switch it yourself, right? Just this slide.
I know. I was testing it in the other room and it was working, so I'm not sure. What the hell? Maybe now. Yeah. God bless. Myslím, že hello, can we start? So let's close the door, please. Thank you. So it's just too much noise. Hello, everybody. Thanks for joining our talk. My name is Miroslav Atkerti. I'm here together with Jan Havlin. We are both developers on the testing farm team, and we will be presenting today about the testing farm environment profiles. Let me reset the counter. So yeah, this is what we have prepared for you. In the beginning, we will do a short introduction about testing farm and TMT. We will look at the test pipeline in testing farm to see how testing farm handles test requests. Then we dive into the details of test environment setup before running the tests, running the actual tests, and we will look at some long-term issues we have with it and how to plan to solve it with this test environment setup profiles.
In the end, we share the current status of the implementation in TMT and testing farm, and yeah, we will look at how we plan to roll this out to Fedora CI, CentOS Stream CI, and Packit, and it also partially applies to RHEL CI if you are a Red Hat employee. So, just a few words about testing farm. If you do not know, testing farm is the testing backend behind Fedora CI, CentOS Stream CI, and Packit, and it's basically unifying the testing experience for the users of the CI systems. The service itself exposes a single HTTP endpoint that is public, and its main input is a Git repository with TMT metadata, which basically describes the details of the testing environment and selection of the tests to be run on those environments. We are focusing on testing or running tests for the operating system, mainly functional tests of the operating system, right? So we are provisioning VMs and bare metal machines. Next to it, for the Fedora contributors, we are providing an easily accessible way of reserving a host and connecting via it via SSH. It's easy as those 4-5 steps. You need to first install the tool and onboard to get a token as a Fedora with the Fedora single sign-on and just get your hands on a hardware that we support. You can also request beefy VMs, bare metal hosts, and GPU instances, and I would very much like Amazon to sponsoring Fedora to provide this hardware to you, Fedora contributors, and making the CI better. A few words about TMT itself. TMT is an open source test metadata format stored in Git repository, and it's also a convenient CLI tool for discovering, developing, and debugging tests for the operating system. With TMT, we were able to unify basically how the operating systems operate, the tests for the operating system are defined and shared across like projects, upstream projects, Fedora testing, CentOS Stream testing, but also RHEL testing, and Rivos testing, so it's like a unifying piece for the operating system tests. It's packaged in Fedora. It's really easy to install it. In the example below, you can see how easy it is to actually run tests for Bash component, which is using TMT. So it's like really like super easy. I will hand over now to Honza.
So I'm going to briefly describe the testing pipeline that testing farm executes to point out the focus area of this talk. As Miro said, testing farm exposes a single HTTP API for users to request test execution. So users have to provide a description of environments they wish to run tests in and a Git repository URL with TMT metadata. And once a user submits a request to the API, testing farm pipeline will begin its execution. I'm sorry. The execution pipeline consists of several steps. First, the requested Git repository is cloned to discover TMT plans. Then a testing matrix is constructed, so each TMT plan is executed on each requested environment, and the plan execution consists of provisioning a machine, running guest setup or environment preparation, executing the plans via TMT, and reporting results. In this talk, we are focusing on environment setup, or we call it guest setup as a legacy name. It consists of 3 phases: pre-artifact installation, which is implemented by an Ansible playbook; artifact installation, for example, installing Koji build or other builds; and post-artifact installation, which is again an Ansible playbook. And the main focus area is the first phase, the pre-artifact installation. This part is implemented in Ansible as a single playbook, as I said, and it's importing some task files. We are maintaining the code in our infrastructure repository, close to our infrastructure as code. In testing farm requests, we are exposing logs from the Ansible execution in the results viewer, so it's quite a bit nicely discoverable by users for the execution. Some examples of the tasks are updating the system and restarting if necessary, installing Koji so we can download Koji builds later on, and install the RPMs, setting the time zone, enabling some other repositories such as Apple or others, and so The current implementation has a couple of issues. I'm going to briefly describe them and say how we are approaching the issues to mitigate them. First thing is that they are a bit hidden in our infrastructure as code, and they are not easily contributable by users. And they are being imported as tasks, and they are not modularized nicely. As a solution, we are moving them in a separate repository called profiles, and we are rewriting the tasks into Ansible roles and structuring them into collections. And we will say more about the structure in the next slide. Another issue is that currently the guest setup or the environment preparation is implemented by a single playbook, and it's used by all our users or CI systems, and each CI systems has different requirements, which results in messy code with many when conditions, and which are based on the image that's being run on. So as a solution, we are splitting the logic into separate profiles based on the user or CI system that's executing the request, and each profile will be implemented by an Ansible collection in the separate repository. As a result, it will be more easily contributable, since the contributors will be able to focus on just a single profile that's interesting to them instead of the whole thing that's getting quite over the hand. Next issue is that testing of the guest setup playbook is done as a part of our infrastructure integration tests, and we don't expose them publicly due to some credentials and other sensitive information about our infrastructure. So since we are moving it to a standalone repository, we are enabling CI just for these profiles, and we are able to make it public. We will show it, we will run it in public range, and it will be contributable by users from forks if they provide their own testing farm token to the forked repository. Another issue is that the current implementation is not easily executable locally using TMT, so we don't include this part in the TMT reproducer script, which is available in every testing farm request. So that means the reproducer script is not matching the testing farm production. So it's not possible to reproduce the same environment locally. We will be distributing these collections using Ansible Galaxy and RPM packages, and they will be consumable by TMT Prepare plugin. And this will allow users to reproduce it locally. We will be able to include it in the TMT reproducer, so the environments will be more close to the production. Currently, it's not possible to change or disable the test environment setup. So it's not so clear what's the playbook that's being executed. The code is a bit hidden, and we will allow setting a guest setup profile via testing farm API or in repository configuration, because in the future there will be no preparation by default. Users will have to set it themselves. And we will also have to improve the visibility in our results viewer and add a link to some documentation, because currently there is no dedicated documentation, so we plan to add some documentation to the collections and show it in the Ansible Galaxy. Okay, I will hand it over back to Miro.
Okay, yeah, so as Honza described, for each this use case or the CI system, we will have a dedicated Ansible collection under this testing farm profiles namespace. And yeah, that will be basically providing a unified playbook apply YAML. That will be basically the entry point to like set up this profile on the machine, right? Yeah, there will be separate collections. separate profiles for the CentOS Stream CI, Fedora, Packit, and it will be easy to add new profiles. So if somebody wants to have their own dedicated profile, whatever, we'll provide good support for that, so they can fine-tune basically the test environment setup as they need. Like this was not possible before. This setup will also make sure that only the relevant setup for that CI is done. So, and it's vetted by hopefully the users. We would like that the Fedora CI, CentOS Stream CI users will be able to basically change the setup if they want to, and there will be some consensus. There was also some discussion if we should not move it even closer to the CI systems, maybe to in the repositories of the users like Packit or Fedora CI, but for now we will use this single repository to maintain a good CI setup. As you can see, like that's the layout of one collection. There is missing. It's brief for the presentation. There is definitely missing some required missing.
3 collections. No?
Yeah, for each profile there will be.
Yeah, you said 1 collection, but I see 3.
On the picture there are 3 collections for the different users. Thanks. There are some missing files like the required collection setup. One thing that I want to point out is that we will be having basically a TMT plan which will run validation tests via GOS. So if you don't know GOS, it's a simple server validation framework similar to server spec or test infra. Those are like or RSpec, and basically that verifies that the profile was applied correctly, right? So we will have this good CI setup, and you change something, there will be no surprises that like something was broken. This GOS test will be currently run only for CI purposes when they will do changes to the repository. And the profiles will be properly tested on all supported composes. So really contributing should be easy. There should be mitigated any possible things of regressions. Next to these profile collections for each user, right, there will be a special collection called library, which will host roles for specific setups. As Honza showed on the previous slide, we have setup for EPL, setup for like time zones and so on. So this will be a role under the library collection, and this will be reusable roles which the profiles will then use and cherry pick actually what they need, right? And the apply playbook will actually import those roles and cherry pick the specific setup functionality. And it is expected that some roles don't make sense for some of the profiles, so they will be not used. But otherwise, we are making the roles in a way that if you run, for example, Apple installation Fedora, it doesn't fail. It just does nothing. It informs you that, sorry, like Apple on Fedora obviously doesn't make sense, right? And the similar approach, that's of course the layout of the library collection. Similar approach will be used for the testing. Like there will be a GOS test for each role that will verify that the role is doing what it should be doing, and actually the GOS tests from the profile will actually be including this or cherry picking also this GOS setup from the roles, so they don't need to they can verify the functionality that is defined in roles, or they will be able, of course, to define additional setups or additional checks if needed. We spent good amount of time for a well-working CI. The example on the picture, you can see a screenshot of GitLab CI, which uses parallel metrics job, which is actually generated. So we generate the GitLab CI configuration. So we have one single source of truth of the all supported environments and combination of virtual machines and containers. We are testing these roles on container environments, but also virtual machines, and we'll be extending this for RHEL and anything else. There are some auto SD images that we use and so on. So we'll be extending the test metrics more. So we made it very simple to add new environments, and the required configuration for GitLab CI will be nicely generated, so I'm really happy about that. On the screenshot with the black background, that's actually an execution of one of the environments, and you can see that it's running basically tests for, it's running those GOS tests for each library and each profile. Workarounds is actually another library that we will use for various workaround stuff. It happened, for example, before that Fedora Rawhide was broken because of something, right? So when that happens and we need to apply workaround for Fedora CI just to make it work because of the DNF5 changes or whatever will come in the future, so workarounds will be a special special kind of collection that we will like, or the community will be able to like add workarounds for the specific issues that really need changes and so on. And yeah, on the right side there is the testing farm output for a specific test where Ghost is running. I think that's for the time roll where yeah we are verifying that the time zone is good and there is some expected output from Chrony, I think, with the setup NTP servers. Okay, now let's look a bit more concretely how the profiles will be applied in TMT. This might be, that one was like interesting, but this might be more interesting, like how this will be used, right? So yeah, so how the profiles will be applied by TMT. So in version TMT 142, TMT gains support to be able to run playbooks from an Ansible collection. So that's the first example, right? So if you do not know, you can run a playbook from a collection with this notation. It's normal Ansible notation where there is a namespace, testing our profiles, name of the collection Fedora CI, and there is the apply, what is the name of the playbook, apply YAML, right? So TMT gains support to be able to run these playbooks, which are actually like provided by collections installed on the system. And in TMT 144, there was introduced a shortcut for this. So the new prepare feature plugin was created that you can directly specify a profile. So currently we have also the namespace prefix here. I think it makes sense, but like it's basically just a shortcut to the other thing. And yeah, once actually testing farm will be this running in the future, but also like how people will be able to run this on a command line is that they can extend or add the prepare features. That this is not adding it, is completely replacing it, but you get the idea. In terms of testing farm, we'll be introducing an easy way to set specific profile in the environments. For a specific environment, you will be able to specify which profile should be used. So yeah, this is the way how Fedora CI, CentOS CI, Packit, and other users will set the profile when they are like testing farm. So they will most probably need to have some mapping like that. When Fedora is used, then they will use. It will be actually their decision, like what profile to use. And that first part is actually part of our API. So it's our API, how you in the API call actually specify the TMT profile. Yeah, because we want configurability, it will be also possible to override the profile using this in repository configuration that we introduced. So you'll be able to, like, if your repository needs a different setup, you'll be able to override it and get yourself through the struggles if the profile would be not good for you, right? And yeah, the last thing, it will be part of the reproducer steps, as Honza mentioned. So in the reproducer, you will again see the TMT commands. So this is basically the last step that will bring you the configuration that testing farm is using to run your tests. So yeah, a lot of problems in the reproducing should be limited this way. Yeah, and let's look a little bit briefly how will we bring to our main public users. So we have finished like bootstrapping the project with good CI, and currently we are porting the tasks files that we have to these roles. I think we are like 70% done. We need to do some reviews, and I think it will be finished, like the porting for public range will be finished, like I believe in like 2 weeks. We would get there. Once that is done, like we will be moving the testing farm to use these roles instead of those tasks. So we'll be depreciating that old code. But testing farm will still like use this old default profile basically that it will apply to the hosts, right? And in the meantime, we will work with Packit, Fedora CI, and CentOS CI to actually use the profile option, so they can select the profile that they will be using. And once all users are using, or the major users, so we don't break users, are using the profile, then we will drop the old code and make it nice and so on. So in that time, testing farm will not apply any playbooks anymore. It will be a complete vanilla and do whatever you want kind of thing. I'm not sure if everything will work, like obviously CentOS Stream 8 and so on will be not even working because the repositories are not working, right? So, but yeah, we will provide this vanilla experience. Also for the RHEL users and internal users, this is one of the things that we want to come up with, that there will be a possibility to really get that vanilla kind of experience. And for some tests, it's really needed. Oh yeah, 3 minutes. We have 3 minutes still on the presentation, but that's all what we have for you today. So, open for questions if you have any. Yes. The microphone. Sorry.
So if writing the tests in TMT, I'm able to test those locally, right, before I push it to testing farm. Since you are configuring the environment using Ansible, are you able to automatically run these Ansible scripts against the local container environment that I'm using for local development?
You will need to extend basically your, ideally the plan, like you will need to specify which profile you want to use, right? So we are thinking that, for example, if you submit it via testing farm CLI, like itself the tool, like not speaking about local, then testing farm CLI can say that, okay, you are using source Fedora project.org as the source, and that is actually Fedora CI, so it will apply by default the profile. But for plain TMT, run locally, I think your plan, like for the local use case, should define the profile. But it's all like, it's a good point, like why should you do that, right? But TMT would need to know from somewhere which profile to apply. Like for example, if you would have cloned this Git repository, maybe it's clear that we can do that mapping for you, but I think that's a good discussion topic. Like again, testing farm CLI will do that mapping for you. It knows the Git repository. We are actually setting some, for example, context and so on automatically. But for plain TMT execution, it's common that users have their own local setup, like in the plans, using adjust rules to basically change the behavior to the local execution. So at least for the start, it will be required if you will want to use profiles, then you will need to add it to your plan and adjust it for the local execution. But it's a good discussion topic if we should do some automatic kind of thing. And it will work for container provision, of course, because, yeah, thank you. If you are not a Silverblue user, as I am, because, okay, that's good. We need to fix their problem because it's the Ansible playbook is run via podman unshare, and in Silverblue, when the container is run on the host, not in the toolbox, it doesn't work. So I'm really not happy about it. But like in general, it will work. Like we are trying to make the as you saw on the CI page, we are testing it against all container versions. I think we will skip maybe rel, but Fedora and CentOS will be tested on containers and virtual images. Cool. Yes.
So what are the plans for backwards compatibility? So let's say we have the profile for Fedora, and then we want to disable installing the packages by default, or like doing these kind of changes over time. Like if we just specify the profile, then it will take, we would have to like change everything, all of the packages at once, like all of the dist-git packages to install their own prepare them. So like, is there any kind of like backwards compatibility?
So this what you are presenting doesn't deal about the artifact installation. That's something that we hacked into the reproducer steps. It's and TMT will be gaining a new plugin to completely install the artifacts. Just saying that it's not tied to artifact installation. But it's definitely a good point. Like I think that where we are getting in is that we will have profiles for the CI systems, but it will be not just about test environment preparation. It will be also about more things like by default running AVC checks for Linux. What is requirement for rel might not be requirement for GitHub actions like triggers, right? Or testing on GitHub projects or whatever on some things. So I think we will get back to this problem. And I don't have now a solution, but if we disable the automatic installation of the builds currently, the testing farm does, we will break somebody. So yeah, we will need to think about it.
But this is more about the design of the profile. So let's say at some point we have tested it against the profile and everything works. But as time goes on, like those profiles change. So like, how can we be compatible with the previous versions that was working?
Yeah. Definitely a good point. Like we can store the checkout of the profile in the artifacts.
Okay, thank you.
So it's not done a file an issue, so don't forget, but definitely a good point. This is, we are searching for feedback, so this is a really valuable feedback. Christian, thank you. So, okay. We are still time.
Since the microphone is here.
Yeah.
So this was the first time I heard about GOS. So I'm just wondering why was it chosen, or like, is it because it the synergy with Ansible, like the YAML syntax, or?
Well, GOS is really easy to like run because it's a Go binary, and you inject it. We use it for any like testing container images if they are prepared correctly. If the virtual machine is like the content of the server is correct and so on. So we have some experience with it, and it's really easily approachable. It has quite good community. Maybe not the largest one, but I think like this, and it has a good support for container images. It has a wrapper that GOS is like a Go binary, and then it has a dgos wrapper, which is able to wrapper around Podman or Docker, and it can easily execute a testing container. So yeah, we chose it because it's like a lot easier to install some Python or some Ruby application directly on the machine, and it's built for all the architecture, so we can use it across the board. And it's really like this easy distribution. I think that was the main selling point. Also, the YAML format is quite nice, and it's very fast, like because it's Go and it uses multiprocessing, so it's like really like gets the job done really fast. So that was the reason. There is some good Ansible integration, and it's like really like it has a good community if you check out the GitHub. So yeah, a little bit selfish reasons, but I think also we save a lot of like effort. No need to deal with Python installation, you know, into the containers and so on. It's a big stack, and this is just a one binary. So,
thank you.
You're welcome. Thank you. Thanks for joining. Enjoy the rest of the conference. Dobrá práce.
poutík, jo? Ať se tady nebouk, tady zase za tebou je obrazovka, ať se neboukneš, i když ty asi by se spod to vlezl. Jo, tak tady je kecpoutík.
To je fajn. Jak si to představujou, to ten setup?
Tady je mikrofon potom.
Jo, to zkoušíme pak.
Přímo před tebou.
Nice.
Když tak si vytáhni ten notebook, teda na ten kecpoutík, je tady
co mají HDMI? Mají HDMIčko jenom, OK. Tak HDMIčko. Z které strany to bude lepší, kde ho mají, nalevo nebo napravo?
Co hledáš teď? Mikrofon?
Ne, přemýšlím, že tady mají to HDMIčko. Jestli bude lepší, jak udělat napravo nebo nalevo s ním.
Je nevědomý, tak
je to asi tak jako jedno.
Počkej, co hledáš teď?
Bude lepší to HDMIčko zleva nebo zprava?
No, tady
potom.
je, tady z této strany.
Jo, spíš nalevo, tak jo.
Ale dá se to jako na obě strany,
a mně to je úplně jedno, protože stejně budu měnit jeden z těch...
No, já musíš předělávat.
Musím, protože tam HDMIčko nemám.
Jo. Jo, to jsou právě vyměnitelné všechny ty porty.
Jo, framework je fajn náhodou. Plesk. No, teďka samozřejmě se to pošlu někam do háje. Uvidím se velký kulový. Audio někam do kša samozřejmě, předpokládám.
No.
Jo, jako měla by tam být nějaká plocha snad.
Ale tady to ještě nepřešlo.
Jako řádek jsem se nevzal, takže jako debugovat se to jako bude bez toho audia pěkně stupidně.
No počkej. Ono tady je i zvuk, jestli chceš zapojit do toho.
Jako na debugování možná, ale jako potřebovat ho nebudu v té prezentaci náhodou.
No a co ti to udělalo? To by to hodilo na darovou obrazovku? Nebo
nevím, jako...
Udělalo ti to externí...
Co já vím, co to udělalo? Hlavně to...
Můžu se podívat? Já se podívám do nastavení.
Hlavně jako si myslím zcela nehybně.
Displeje. No, mně to spíš přijde, že to ani...
Že jako nefunguje ta věc.
Že to že to rozpoznalo ten, víš? No, vypadá to tak. Víš se, tady mám ještě, když tak rozbočovač na USB-C, můžeš to zkusit přes USB-C plug. Nedá, aspoň myslím, že ho mám někde. Jestli jsem ho nechal.
Je fakt, jakože HDMIčko jsem fakt jako netestoval, protože nebylo moc kde. A to června jsem ho jako nepotřeboval s těho novým kompem.
A USB-C ti funguje, jo?
To funguje vždycky, ale aspoň na to, co potřebuju.
Tak uvidíme. No jo, toto se chytlo, super. Jo. Tak a teď ty to chceš mít jako zrcadlení, anebo to chceš mít jako druhý?
Mně to je asi jako úplně jedno, protože stejně, jakože v háji to audio, tak jako, když to posouvá, tak jako rád, takže jako asi si to nastaví, jak se ti bude hodit tobě líp.
A ty tam máš nějakou prezentaci?
Jo, kde se válí ve stažených souborech. Jo, teďka už to audio je fajn.
Stažené.
Jo, to je jediný ODPčko na začátku.
Jo, vypadá to, že to tam je, super. Jo, takže přepínat ti budu potom já, tady je tam potom ten mikrofon, ještě tak ten baťou mám ti ho dát někde dozadu, abyste ho nezakoupil.
snowboardači.
No, a já ti dám tady trošku víc dozadu, kdyby náhodou.
Když to jako nepodělám. Máme času dost ještě.
Jak pozor, tady trošku, no a je tady hrana toho té obrazovky, nebo toho plátna, jo?
No, ještě máme jako tunu času, no.
Je spíš se jako jdeš tady víc doleva ke mně.
To si nevadí potom.
Co?
To mě asi jako nevadí.
Jo.
Je trochu smutný, že jako jenom názvy slajdů zabrali celý pražský papír.
Skočím na pití, nechceš jít taky třeba na tomku nebo něco?
Tak jo.
A chceš pevivou, anebo nepevivou?
Klidně pevivou.
Jo? Tady ti dám potom kecku, tady se napij, klidně. A baton máš. Úplně si odejteš to. No, kdybych chtěl dát tady pod ten kecpultík, vadilo by ti to?
To nevadilo.
Tak já tam vlastně věděl, že to máš. Mají tady moc pěkně pod tím kecpultíkem mají velký monitor, na kterém můžeš sledovat ty slajdy, to co máš, což tebe to nejde úplně.
Jakože pro vědomí jako ten setup má něco jako fajn, to si ne, že ne. Čtení prezentací v LibreOffice jako to ještě má to prostě jako dost daleko, no, ale to funguje jako učitelně. Ironicky to jako líp funguje v Google prezentacích, ale jako nejsem tak zoufalý, jak to musel prezentovat přesto. Jako ty titulky je jednodušší. Papír se může akorát ztratit, ale funguje vždycky. Souhlasí, aby nebyla vidět na kameře.
Jo, počkej, já ti dám tady pod to.
Láhev jako na kameře fakt nikdo nepotřebuje.
Potom si řekni, kdyby si zase chtěl, jo, a tě ji podám.
Jo, to si
neměla vidět na kameře.
To je dobře.
přeneste úplně nikam jinam.
No, což je, víš.
Tak potom pozor, no, máš, už tady stojíš v místě, kdy jsou tady, máš před levou nohou kabely a pak tady hlavně potom ten stojan na ten iPad, ten krabic, takže potom na ten se posuň tak o půl metru do pak.
Že se jednou se nastavit mikrofonu, jako video jsem, co stojí.
Ahoj Lukáši.
Ahoj.
Potkali jsme se na Uberautu.
To možný.
Ještě s Ondrou Kolínem jsme tam.
Jo, jasně. Jo, to byla taky akce.
Máš se?
Jo, docela dobrý.
Jaký novinky?
Docela je novinka, no. Nebo jako práci, ještě taky na 3 prezentace. Ale pak určitě najdem další za tu dobu. To dá nějakou fixne to všechno.
Ty jsi tam s Čerejškou, že jo?
Co?
Od Čerejška, že jo? Já jsem s tom musel vykomunikovat doma, vzhledem k tomu, že minulý týden jsem byl s kamarádem ve Znojmě, tenhle týden jsem tady a příští týden budu 3 dny v Brně, tak se nemůžu stěžovat. Já jsem se skoro bál to doma navrhnout. Dělal jsem to asi půl roku předem, to všechno. To takový to zlato nevadilo by ty kdyby. Tak jsme tady vyčenčovali, že mě čekají nějaký celý víkendy s dětmi. Nebo jinak, já jsem tím začal, že jsem vzal děti na 4 dny na Šumavu.
Děti starší, už to v pohodě, když byly úplně malé, tak to bylo jako malé. No to je staré. To je ještě málo, no ale...
Já mám vytipovaný takový jako už místa, který už znají z minula. Máme takový hezký kemp a tam jsou i chatky. V chatce ti dají elektřinu, ledničku. Vím, kterou chatku vybrat, která je nejblíž hygienickému zázemí, těch klíčových 20 metrů. Takže když pak takhle odnesu ty dvě děti na rukou ze sprchy, tak jako to není až tak strašný.
Ok, jestli ještě napít, tam taky. No, ale 5 a 8, no, tak to budou mít 6 a 9 a to už se dá. To už se dá.
To dáš a vždycky a kašperk a už tam mají svůj oblíbený pařez, na kterým se každý rok chtějí dramaticky fotit. 3 nebo 4 ročníky za sebou, což je zradné vidět, že na začátku teď to fakt bylo malý, rok 2.
To může být do té fotky, když mě porovnáš.
Tak jo, za chvilku půl, krásně budu počít, takže soustředění.
Dobrý bude. Okay, good morning, everyone. So let's learn something about accessibility and how difficult and rewarding as well it may be sometimes. So let me first introduce myself. My name is Lukáš Richter, and I am working at Red Hat in the tools and accessibility team as a software engineer. Most of the team is working on the tools part, but I'm working on the accessibility part. Of course, one of the reasons is that I'm blind, so I meet these things quite often. But it may be an advantage, but also a disadvantage, because we need new views, because as we use the computers, we learn basically what's wrong and don't care about it or stop doing that. So if anyone wants to help, go forward. But before we get to the presentation, I'd like to thank all the upstream maintainers, because without them, the situation in accessibility would be much worse. So thank you, everyone, for doing a great job. And let's go to the next slide and actually learn what we will be talking about. First, we will learn how the visually impaired use the computer and why it's so different, why we need keyboard access and features so advanced that the security guys are frightened of us. And it's not everything. We have next slide with the agenda as well. And in the second part, we will look on the technical side. We will tell the story of how keyboard input monitoring actually works, how it worked, and how it will work in the future, I suppose, if anything doesn't happen so much. And that's basically the plan. So let's move to the next slide. But before we get to the interesting parts, we probably should get some terminology out of the way. So first, let's a little bit describe how a screen reader works and what it actually is. A screen reader is a piece of software which tells a visually impaired person what's on the screen, and it also announces changes of the screen content and allows the user to interact with the screen content, like reviewing the text of the screen, telling you the formatting, like the font size, and so on, of some controls, and so on. And on Linux, we have basically only one screen reader which we can use, which is named Orca. But of course, we have screen readers on other platforms as well. Apple have its voice-over screen reader family on its devices. We have Tollback on Android, and on Windows the situation is much more complicated, because while the platform was promoted to visually impaired, so we actually have or had a lot of screen readers there, but the most known today are probably NVDA, which is fortunately an open source screen reader, so that's nice to have there. And then we have commercial options as well, but this is Flock, so if you want to know more about this let's talk about after the presentation. And let's move to the next slide. Well, a screen reader needs to tell the user a lot of information somehow, and it most often uses something called the speech synthesizer, which basically gets some text as an input and it produces some sound as an output. Well, on Linux, the screen reader isn't talking to the speech engines directly. It uses a user session daemon called speech dispatcher to do this, so the screen reader developers doesn't have to interface with all the synthesis engines and can just say, hey, say me hello to the user with this voice rate and so on, and it basically happens magically for them. And the most common speech synthesis engine on Linux is called eSpeak, or more precisely, it's eSpeak ng fork, which is derived from eSpeak, which happened a few years ago. But we actually have more options there. We have Festival. Unfortunately, the development has slowed a little bit in the recent times. Then we have RH Voice, which is quite nice if you give it the right data for a voice. So yeah, the English voices are quite nice, but we have only a few, say, Czech voices to select from, and I would like to see more, but yeah, that's a good idea for a contribution, I said. And yeah, the AI wave didn't miss speech synthesis landscape as well, so we actually have Piper TTS, which uses some neural network magic to do the synthesis part. And there, of course, very much depends on how good your training data are. So the English voices are quite nice, but the Czech ones, it's a personal opinion, but they sound quite weird to me. But the computations aren't so complicated, and you don't need some huge graphic card farm to run this thing. So it's quite usable if you have the right voice. And yeah, that's everything I wanted to say about speech synthesis for now. And let's move to the next slide. And we actually will talk a little bit about how the visually impaired use a computer, because I very often still hear the same questions again and again. So let's get them out of the way. Most visually impaired users use a normal computer with a normal keyboard. Well, the reason is quite simple, because if you would have some special keyboard, the price of the hardware would be, well, at least crazy, maybe insane as well. But yeah, some of the visually impaired actually use some specialized hardware devices, but they are limited in various ways. Most of them, or well, I didn't hear about anything isn't open source, so there are software limitations, the prices are high and so on, but it's an option for some of the visually impaired, but the majority is using a normal computer. Of course, we have to learn typing the keyboard without seeing it. We aren't using some marked up keyboard. We are using a normal one. So this is actually done quite early in the life of the person. Personally, I started learning the keyboard even before I had my own computer. So I'd say that was a good decision because I wasn't lost after I got the computer, because there was still much more to learn, because we naturally can't use the mouse. Or, well, for some gaming scenarios we can, but it's not very common, and if some audio game developer actually tries it, he very often gets messages like, well, I have no mouse, do it differently, please. So after we get a computer, we have to learn all the keyboard shortcuts, and there is a lot of them, even without using Emacs, which some of the visually impaired actually do. But personally, I'm sticking to the, well, little bit more mainstream user interfaces, so I can actually fix the issues for more users. And after we learn all the shortcuts, we actually need the applications to be keyboard accessible, and that's another very complicated topic which we actually had some presentations about before on FOSDEM or DEFCON. So if you want to learn about this aspect of accessibility, you definitely have some materials to use. But that's not this session's topic. So let's move to the next slide and actually start talking about the main thing of this presentation. But before we get to the what happened thing, we actually need to get out of the way why actually the visually impaired users need so weird requirements for system hardware access. Basically, the screen reader definitely needs to see all keyboard events and do something with them. And, well, if I could change the world however you could, we would have some API for emulating mouse input as well, for reasons of some inaccessible web pages mostly. And we would have also some API to make arbitrary screenshots of a window and a specified rectangle in it. And we could, of course, then pass this screenshot to a large language model and get some nice description of the screen, which would be so nice to have on Wayland for, say, virtual machine installations and so on. But, well, these topics definitely will be covered in some future talks, but no, this isn't this one. This is only about keyboard input, so let's move to the next slide and actually go through the reasons the screen reader needs the keyboard events at all. One of the reasons is quite simple. In theory, the screen reader has its own keyboard shortcuts, and it has a lot of them, maybe in the tens or hundreds. And so if you don't want to clash with all the other system ones, you have to often basically invent a modifier key, which is something like Control, Shift, or Alt, but something different. Most often it's the insert key, or if you don't have the insert key, you can use the caps lock key as well. So you need to invent this modifier key, and then you have all the shortcuts for, say, telling the current time, the battery status, system load, the current window content, the next line of the window content, the font parameters on some position for copying the content to the clipboard, and so on and so on. There are really many of them. Some of them also open the screen reader configuration, so you definitely want to be able to do that. And for this keyboard shortcuts, you actually want them to be consumed by the screen reader, and you don't want the compositor or the applications to see them at all, so you don't do something unexpected in the application. So you just eat the shortcuts, do something, and that's it. But we have other kinds of shortcuts. So let's move to the next slide and look at them. The visually impaired user very often wants to hear what is he or she typing on a keyboard. So you need to see the keyboard events for this as well. And you can't actually restrict this to text controls. You want this service to be available everywhere. So it's consistent and not surprising for the user. So you want to see the shortcut, see the event, but now you want to pass it along, so it actually does the usual thing which it does in the application or compositor. And that's not enough. It's not all. We have a next slide with the shortcuts thing. Well, this use case is probably a little bit Orca specific, but when you are moving through some text controls by line, by word, by character, you want to hear where you actually moved. And at least Orca uses the keyboard events to help it determine whether the user actually moved the cursor and how much. So if you don't get these events, you end up silent in text controls, so that would be also quite bad. And naturally, you want to do the cursor movement as well, so you don't want to consume these events as well. You just pass them along after seeing them. And let's move to the next slide. Well, when the speech synthesis is speaking, it may be something quite long and you don't want to hear it completely. So it's handy if you can just press some key and the speech stops. This is very often done using the control keys. So you don't want to see them, but you are also passing them along. And let's move to the next slide. So in summary, the screen reader basically wants to see every keyboard event, every key press and key release, even for modifiers and so on. And then it can do basically two things. It can basically consume the event, so nobody else sees the event. It doesn't do anything in the applications or compositor or whatever, or it can just observe it and pass it along, so it does the usual thing as well. So let's move to the next slide. Well, now we actually know what we need for a screen reader to work. So we can actually learn how, in the technical sense of things, it actually worked. And it will not be easy because, well, it was a story, I'd say. So let's begin with how it actually was working in the past on the next slide. Well, before we can explain it, we have a system component we weren't talking about yet. It is named the ATSPI2 registry, which is another user session daemon, which does a lot of accessibility-related things, because you actually need to find out the root of the accessible tree, but, well, the tree is something which tells you which controls, windows, buttons, and so on exist in the tree, but it's not this time important to do this functionality, but in the beginning, it actually was quite responsible for keyboard event reporting as well. So when a screen reader wanted to get keyboard events, it basically connected to this registry daemon, got the accessibility dbus bus address connected to this dbus bus, so the session one actually wasn't handling all the traffic. We will see why in a moment. And then it basically told the registry daemon, hey, I want to watch all keyboard events. And yeah, the daemon say, well, okay, I will just do it. And we have the other part of the story. We have the applications, which are also connected to this daemon. And when they received a keyboard event, they told the daemon, hey, the user pressed, say, E, for example. The daemon went through the list of subscribers and sent them this keyboard event. And the screen reader was responsible for a reply which basically told the application whether the shortcut should be consumed or not. So you had to go through the registry daemon, and the reply got to the application after some delay, of course. And the application had to honor the decision as well, so things would work. So you had a lot of traffic on this bus. You were bound by some latency for each key press in applications. So naturally, this situation wasn't the end of this story. And on the next slide, we will learn what GTK4 did. It was released in 2021, and one of the big changes in GTK4 was the complete rewrite of the accessibility subsystem. It was now handling the communication with the ATSPI registry daemon directly without any libraries. And one of the decisions in the GTK4 refactoring was to drop this sending of the keyboard notification events. So now we had GTK4 applications with broken keyboard input for screen readers. And as a result, we naturally needed a solution, which is described on the next slide. In 2021, not many users or at least not many visually impaired users were using Wayland. So we weren't taking Wayland into account in this time. And the solution was quite simple. We created a new API for keyboard event monitoring, and this API could use various sources of information. It could use the old legacy API, but when we managed to get a hold of a X server, the API requested the key events directly from the X server, and by some, well, I think by horrible magic with keyboard grabs on the X server layer, I saw the code and I actually didn't like much, but that's what we had. It actually supported this consumption of keyboard events by the screen reader as well. So now everything was working as intended as well, but as the time moved on the next slide, we find out that Wayland actually happened. And yeah, we suddenly didn't have any X server. And the X-Wayland layer was no help for now because the Wayland compositor couldn't supply the information to the X-Wayland layer as well. So now we were basically where we were before in GTK4, which is described on the next slide. Now we had a GTK4 application which wasn't sending the legacy keyboard events, which was the only source of keyboard events which remained on a Wayland session. So in a GTK4 application, you could do nothing screen reader specific. Actually, you couldn't stop the speech, you couldn't open screen reader settings, you couldn't review the window, and you couldn't even read a text box. So the situation was quite, well, I'd say sad. And after some time, something had to happen. So let's actually move to the next slide and talk about it for a while. Well, because Wayland was so much common than a few years ago, Fedora 42 actually wanted to actually drop the Wayland XOR session for GNOME, and 12.10 was planning to do and did the same as well. We had to do something about this because first, no visually impaired user would want to use such a system because the number of GTK4 applications was growing and growing as well. So it would come for these behaviors very often, and of course they wouldn't be happy and they probably would switch away from Linux completely probably. And also the European Accessibility Act was there, and the date when it actually started to be mandatory for new things was drawing closer as well. So finally, we started to do something about this. And what? Well, let's look to the next slide. First, it wasn't coding something because we actually had a lot of components which would need to change so everything would work. So thanks to Matthias, we got together with ATSPI and Matter maintainers, and we got talking and explained what will happen and what definitely shouldn't happen in our opinion. And we got together a solution. And let's describe the solution on the next slide. Yeah, I was a little bit lying because, the first draft of the solution was quite simple. It was decided to be a dbus interface because ATSPI was already using dbus interfaces for some functionalities, and calling dbus things wouldn't introduce a new dependency to ATSPI. So it wasn't this valent protocol. It very well could be, but it was much more simple to keep it a dbus interface. And in the first version, this thing was quite simple. You just connect it to the compositor accessibility interface, and you send the compositor a list of keywords, shortcuts, which should be consumed by you and which shouldn't be processed by applications. Even this was already quite nice because now the decision whether to process the shortcut normally or not was handled by the same piece of code which actually got the hardware events, so you had no inter-process communication for this decision every time. So the speed definitely improved. And the compositor could really easily send you the event for all keyboard events, so it actually did. But as it always happens, the first draft wasn't the final thing. So let's go through the changes. The first one of them is on the next slide. Well, it was found out quite early in the actual implementation that just sending the keyboard events regardless of the thing, whether someone actually wants them or not, isn't a good idea. So now, as a screen reader client, you had to say to the compositor, hey, I want to watch all keyboard events, in addition to the previous capabilities you already had. And the compositor said, okay, I will do that. But as we can see on the next slide, this open design wasn't the final thing to exist because, well, you don't actually want API which basically gives you a keylogger capability without any work. You just could run as the user and ask the compositor, give me everything the user types. And you got everything without any question asked. So this definitely wasn't the best thing to have. We actually needed to limit the access to this interface to some privileged clients. Well, how this access control actually works, it's nothing sophisticated. There's no cryptography handshakes or so on. It's just a check for owned dbus name, which is enough because most often someone else couldn't claim the name because it already exists on the bus. The list of these names needs to get to the compositor somehow, while for now it's a hard code list. Of course, in theory, the compositor could do anything. It could ask the user for confirmation, and maybe it will in the future if we introduce, say, a portal for that. But we wanted to do anything to move this design to the finish line, so no interactive things were implemented. And of course, this decision is compositor dependent, so for example, Matter could behave quite differently in the access control checks than the others. It didn't happen yet, but it definitely could. So let's move to the next slide, which, well, is quite happy because now we had a working prototype of keyboard monitoring which worked everywhere on Wayland, Xorg. It actually, well, didn't actually much care, but it basically is mostly useful on Wayland, but now we had to get the things upstream. It required a few changes. First, of course, we don't want to rewrite the screen reader so much, so I created a backend to ATSPI which uses this interface for reporting keyboard events. This actually was merged and got to the 2.55 ATSPI release, which happened a few months ago. And then, actually, we needed some screen reader changes, at least a little. The old interfaces were using hardware keyboard codes, so that wasn't quite good because you couldn't even reliably get the key map and get these codes on Wayland. So we decided to use XKB key sims instead, which anyway every compositor uses somewhere in the keyboard event processing, so that wasn't nothing new for the compositors. Well, these changes into Orca went quite well and were released in the Orca 48 release. And then we have already the client support, and we need to get the support for this interface to the compositors. This was probably the most complicated thing. It took a few comments and back and forth with the maintainer in Matter, but we managed to get this API to Matter 48 as well. So in GNOME 48, with recent ATSPI, everything now basically works on Wayland how I want it to work, so that's quite an achievement, I'd say. But, of course, Matter isn't the only compositor on the planet. We have, for example, KDE and their Quinn, but that's not bad news. We actually will get this interface in KDE 6.4 as well. And I hope the others will join as well because, well, the users probably will want that. And anyway, they probably want to be nice to the blind community as well. And let's move to the next slide. Well, this development was one of the bigger things I actually did in my work. Usually I do some smaller fixes, and so I really learned a lot from this experience. Well, the most important thing is that talking with people is much more important than the actual coding, because when you start talking with people and you get them together, you can come up with some ideas which everyone can agree on quite easily. And then you have the programming, but you already know what to do, what's the right approach, so you just code it. Of course, it's not just coded, because the reality will be always a little bit different, but that's a bit to be expected as well. And yeah, let's go to the last slide. We actually have nothing there because we are at the end, so now it's the time for questions.
Hi, I'm the one who implemented this new interface on the KDE side. So first of all, I wanted to say thank you for pushing this very important topic forward and also doing it in a way that we in KDE could very easily implement. Related to that, I want to ask, do you have any ideas or inputs about how we can, as different communities with the same goals and the same tech space, work closer together on future topics like this?
Well, that's a great question. But I don't have actually any specific answers. Well, of course, there are some at least KDE accessibility or GNOME accessibility rooms. So if someone from the other developer groups would be there and watching what actually happens, that would definitely help. The
GNOME accessibility room already.
Yeah, that's great. Yeah, but maybe that's definitely not everything, but we actually have this same issue even in GNOME, so I'm afraid I don't have much better answers than that.
I'm not too familiar with dbus, but theoretically, what stops some other process from claiming the dbus name?
Wow, I was afraid someone will ask that.
Yeah, isn't it just a race against the clock? Like which process?
Of course it is. But at least for the blind users, the screen reader is the very first thing, or within the very first things which start. But yeah, on a system which doesn't, you probably would be much more successful than that. But making this foolproof would really require some portal proxy and some user verification stuff, probably.
Yeah, thank you. And that's another thing. I've seen Hyperland has some drafts for a protocol of this type, like for global shortcuts. I don't know if KDE or GNOME has something similar, but I've definitely seen it in a Hyperland. So is there like some other option that could be used for a global shortcut elsewhere?
Yeah, we were actually looking on the global shortcut thing before we decided to invent something different. But the current implementation of the global shortcuts protocol requires the user to confirm all the shortcuts, which would bring a quite huge dialogue for a screen reader, which of course nobody would read. And it would just say, okay, I want you to be away. And it wouldn't actually be useful for all the use cases, because you would have the screen reader shortcuts, maybe because I didn't see support for custom modifiers in the global shortcut specification either. But you wouldn't be able to do the speech interruption thing, or you would need to use some quite annoying shortcut. You wouldn't be able to report typed characters, and reporting of moved around text fields wouldn't work either. So we would basically need to make the global shortcuts something like our keyboard monitoring interface anyway.
Okay, thank you.
Any other question?
Yeah, thank you for your work. Basically, all things regarding accessibility are like often start with bad news of what was broken and then it was fixed. Do you have like any coordination in place to avoid breaking things first before they get fixed? Maybe like the group that you, or like the people you manage to get together, have built some teams, or is there something that where we can help to spread awareness about this?
Well, we actually knew about what will happen, but the accessibility stuff wasn't popular hot new stuff in the old times around 2022 and so on. And there were much higher priorities, like rewriting the graphical rendering stuff or GTK or things like that. So even we tried to get to the developers, we probably maybe didn't say it so bluntly, so they didn't understand how of bad news this will be. But I hope that the situation is much better now, because a lot of more developers knew about accessibility now, and the awareness is much more higher. So I'm hopeful that something like this will not happen in the future.
Seems like no other. Oh, yeah, one more.
Do you think it's viable to replace a password-based login with something like security keys for disabled people, or not disabled people, but just really visually impaired people? Wouldn't it be easier for them to log in that way?
Well, you actually can do this. You can, for example, use your fingerprint to authenticate. Of course, then you have other issues like the session keying, security, and so on. So this makes sense, at least so far for me, if you either are using some password anyway, or maybe we could probably do something with Fedora 2 or something like that. But, well, it would probably help other users as well. So I think in the future something will be easy to use. I think we could get to this state of authentication even now, but I don't think it's very user-friendly right now.
Okay, thank you.
One more question.
Hi. What about speech to text? How do visually impaired people make any use of that?
Well, it's quite, well, we have quite huge steps forward in recent years. We actually have now quite good models to do that, thanks to the Whisper family. So you actually can do the transcription of some audio to text locally and pretty accurately. But if you would want to use it for, say, typing text, you would need to integrate it into the input meta mechanism, which actually was done already. But I still think that if the visually impaired user can use the keyboard, it's still quicker and the user can be much more confident about what he is doing. And yeah, still typing on a keyboard is much more private.
Seems like no other question. So thank you, Luky.
Yeah, thank you for going and happy rest of the day.
Já jsem tady trošku potom posunul, že mi utíkal od toho mikrofonu, víš.
Co to nebylo tak strašného výsadku.
No, počkej, co teď? Chci se napít?
Nevím, takhle.
Nebo ještě pevný, počkej, já odpojím tam.
Jo, tohle umožní nám bez... Ano.
Máš tady ještě tu matonku, víš?
Jo, vím o ní.
Trošku vyslovka, ne?
Můžeme vypadnout někam ze záběru aspoň.
Počkej, tak já ti vezmu to matku. Tak počkej, obejde to spíš na druhé strany. Všem si to přehodí, já ti vezmu tady.
Okay, should we start? Good. Can you hear me well? Sounds like, yeah, I'm getting this back. Okay. I'm not a malware. I'm not amplified in that way. So I typically do talks at Flock about our identity management activities in Fedora and RHEL. And this year, I've got rejection on the free APA and related talks, but I got acceptance to talk about something that actually directly stems from our upstream work on free APA. So the malware hunt for fun and profit is largely driven by the events that happened last year, where exec utils were used as a vehicle to bring in a certainly unsafe code into the distributions, or an attempt to bring that. And that prompted me to look at some certain things. So this talk is not about the free APA things, but we will use one of free APA things, components, as an example here, because it's just a demonstration of what really happens in pretty much every modern application. So we have this development of a new, or how we call this, modern web UI for free APA. It's in works for several years already. It's built on a new version of Patternfly, it's built on React, and so on. So if you look, we have basically a dozen direct dependencies. But if you expand those direct dependencies, that will be like 900 indirect dependencies that all of these things pull in. And it's very easy to get to this kind of situation in web application development. This is the server side, but it's also a client side downloaded from the server. So you start with like literally a dozen and end up 900 small libraries and not so small libraries, which pretty much nobody audits. Especially consider that this is going into eventually into Fedora or any other distribution, so a maintainer will have to upload these sources, right? They will be part of, maybe bundled in the upstream tarball. So in no real world, maintainers are looking into that code. So we need to do something. We need to help ourselves as an upstream and ourselves as downstream maintainers to manage this thing. So if you look into the guidelines that we have in Fedora for Node.js applications, it says you just tarball these Node modules and use them, and you upload them with like any sources, and then reference them in the package. That's trivial part, but the packaging part doesn't even start here. Apparently, when you're uploading these sources, nothing in Fedora checks them. They just get uploaded with your credentials, put into look-aside cache, and stay there, can be used for building the packages, whether it's a Scratch build or a real build going into the particular tag afterwards. That doesn't matter. The package is there already. It's in the look-aside cache. It can be picked up by any other package. So it's an attack vector. If somebody is able to crack into the environment where some maintainer works, look-aside cache can be compromised. How we can get the maintainers, how we can get help to maintainers to at least look up what is there. at the time when they uploading something into the looker side hash. How we can prevent Fedora as a whole from the attacks from this vector. And literally, we trust ourselves. We trust maintainers. So far, so good. In most cases, these maintainers are good people and they don't really get. But everybody makes mistakes or slips something, or they get hacked, especially if some state actor wants to attack us. And this is not just a problem on Fedora side. If you look at Debian, they actually build sources on the maintainers' machines and upload the source packages and reuse them. We rebuild those packages, but by large don't change the actual tarballs that are part of it. So it's, can we realistically ask those maintainers to validate all those sources? And validation might mean a lot of different things. It might mean just for the, for example, Node.js-like applications, check that your dependencies do not contain known CVEs, that they are using versions where CVEs are fixed and so on, because later nobody will be checking that. Well, maybe after it's already part of the distribution, it will be checked in. And so it's a lot of work to remediate something that should really be not put into the system at all. So how we can help them, how we can improve. The obvious ideas that I'm describing here, it's nothing new, it's nothing groundbreaking. It's just taking the things that already exist and try to put them in. And it's more like vaporware at this point. It's just an experiment using these existing things to see, can we do this with realistical kind of deadlines, milestones or something, or can this even work? So what we tried is a look at the thing that actually exists in most of the ecosystems that bring us these small packages, registries. So all of them have a common registry thing that is used to distribute the content. So Node.js, they have NPM and NPM registries. Python have the SpyPy registries. Rust have crates, IO, and that's essential part of the infrastructure. Java World has Maven as the register. So all of these registers, everywhere they described prominently from the starting point. If you go to npm.com, it talks about the largest registry in the world. So the side effect of having these distribution ways for software written using these components is that the building tools for these components, they support running with custom registries. So if you go to Rust also says we have a registry, the default one is there, you can run your own registry and so on. So registries are everywhere. Registries can be used for customizing. And apparently there's a business around providing custom private registries everywhere. So people are making a good profit out of it by providing these kind of services where you actually have registers, you track the content and so on. So we looked at what we have and realized that in the group that I'm at in Red Hat, which is the core platform management, which is management of core systems, effectively management of RHEL systems by fleets of different stuff. So I'm looking at the identity management of that, but the guys from satellite are looking at the actually managing content that is being distributed on these RHEL systems. And in their pulp project, which is the upstream satellite, they have support for private registries. They already had support for RPM-based registries, which is bread and butter that they live by. But they also they have support for Ruby, Java, JavaScript, Python registries already. And those are registries that you can populate with your own content and keep it provisioned, updated. You can expire things and so on. So do all the cycle of like life cycle management of that thing. So we were starting looking into how this can be done, and they implemented specifically for NPM registry a pull-through cache. So pull-through cache is basically you point your registry, your private registry, to some other registry. It downloads metadata from that registry, but it doesn't download the actual content. And then when you're building your Node.js application, you're pointing NPM to use your registry instead of global one. And what happens is that the private registry will pull content from the global one that you specify, keep it in the cache, so that for whatever build is happening, this looks like just a normal registry. So literally, you do npm install -- registry, specify some sort of registry there, and then run npm build, and that's it. And if this registry is kind of specified as the global one in the configuration, don't even need to say -- registry. So for packages, nothing changes. It kind of transparently happening there. Of course, in Fedora, we are not using anything like that because in our Koji builders, we have network disabled by default, so you cannot access anything on the network, and we require that you don't run npm as npm install as a part of the build, exactly because it will not work with the networking not available. But imagine that you can point them to the private registries where you have the control over the content. The other part is that once you have this private registry, the content and metadata is there, so you can use that content and that metadata to perform scanning, perform certain operations on it. So one of them is that, again, Pulp guys added is the integration with open source vulnerability database, that project that I think Google leads, and that collects vulnerabilities databases for open source software. It's plenty of different things, so if you go to osv.dev, you will see a lot of stuff there. And there's a vulnerability scanner API they provide, so they just integrated in Pulp ability to request reports against that database. And it supports plenty of these modern frameworks and packages there. So you can ask, is this package that I'm using of this version has any known CVEs open against it? And you get a response, and we will see how this goes. So practically running this reporting is nothing dramatic. You need some setup, but then it's trivial. So you enable the registry so that you get the pull-through caching of the metadata, and then pull-through caching of the packages. You run your normal builds. This is like upstream developer can do this before the release or before verifying that whatever they commit to use, they can do this. And then you do build, collect your resulting things, package them, and so on. So you can run vulnerability checks on the, for example, for the Node.js, the typical thing is that you have this package.log .json file that defines exact versions of the packages that will be used for this build, including the references to registries and so on. And Pulp can accept this file and run vulnerability scanner and do a report about this. So we need the mic to ask the questions.
I will speak loud. So is the fact that the local registry is used somehow connected to the fact of the vulnerability scanning? Could you do a vulnerability scan the same with the upstream registry?
So the question is the fact that the local registry is used disconnected with the fact that the scanning is being done? Can you do this against the upstream registries? The answer is yes, you can do this with the upstream registries. These things are not connected, but integration in Pulp is done for the registries that Pulp backs. So your specific instance has these vulnerability scanning enabled, and therefore you get the reports against the content that is in your registry. So all these effectively can be done manually by the upstream maintainers on their own machines and so on. We want to have something like this automated behind Fed PKG news sources so that it applies to each package that gets uploaded and uses some of these technologies. And less work should be done for the maintainers to do this. So once you ran this kind of vulnerability check, you get some sort of a report. This is a screenshot from my actual run against FreeAPI Web UI set of modules that I used for this experiment. And as you can see, there's this started at, finish it at, and it's roughly 10 minutes. This was like with the fresh cache, checking the 900 packages. So it's not that bad for the individual ones, but it's also asking an external API for validate this package, validate this package, validate this package. If there is a hosted version somewhere internally, we obviously could probably pass the whole package log.json file to the service and say, hey, we want to escape the individual communications. We want to check the whole thing together. Maybe that will be faster. So in reality, what if we effectively have a workflow where we just upload sources the same way we do now, but we don't really make those sources available right away in the local site cache. And instead, we hold them, we detect that this package is actually using some bundled dependencies, and then use the references, because the package will have this logged source information that's typically part of the tarball anyway, and scan against known problems. The way how this scanning could work, because we have all the source code, we have all these references, we can execute a bunch of different things. We can do security scanning, we can do vulnerability scanning for known vulnerabilities, we can do analysis of the code. It will take much longer time, obviously, but if we need, we can definitely consume this. And if no issues found, perfect. We unlock the local site cache entry and allow people to continue building on it. We still keep this private registry with the references. We can reuse them, and we can do something else also. That will be next slide. But if issues found, just provide a report. Give this report back to the maintainer so that they can take an action, maybe record that this has actually happened somewhere, so that there is a traceable event that can be used by, we don't really have a security team in Fedora, but we probably should have some.
One question regarding that. From OpenSUSE, we are allowed to report it directly to the SUSE security team. Isn't that also on Fedora side on this way?
So I will repeat the question. In OpenSUSE, the OpenSUSE can report back to the SUSE product security. Can Fedora do the same? We'll largely do the same. Yes, but there's no like a specific Fedora security team that backs it because it's hard to.
Yes, the SUSE security team is also the OpenSUSE security team in our case.
Right. Yeah, that's possible. And in the cases where, let's imagine this automation actually done, I would imagine that we probably should be making abridged reports with that stuff to the product security as well. But I would prefer if Fedora actually had its own task force for that, because overloading any product security is probably not the best way of handling it. And most of the reports will have things like, oh, this package depends on a package that has a version that already has fixed known vulnerabilities. So it's really about updating that package before allowing it to be built. This is not like a full security problem. But if there will be other scans, other types of scans, then for sure that's probably will require some responsible disclosure. The other part is that we can do, because we have these registers, we actually can basically duplicate the distribution of this content on top of what we have as a part of RPMs. We can distribute them through those registries directly. They are our private registers. They are read-only. They contain the content that we use and ship already, but we distribute it in a way how these communities, like NPM or Rust or PyPy and the others, already know how to use it. This is not a full solution, but it's a solution to the community around Fedora. So using Fedora registries to build your Node.js applications instead of relying on upstream NPM for the builds that you consider, for example, production builds. And same with Maven version, because it is all scales, it's the same conceptual thing. So maybe because we already have them in the RPM format, we just unpack and distribute this thing the same way. And that kind of, it doesn't solve, but it brings us closer to the point of getting the modern programming languages, frameworks, and communities closer to the distribution systems like Fedora. Maybe this is a way going forward. This was just an experiment, and we need to look at this. And going forward, enabling, for example, access from Koji builders towards these private registries only, to be able to pick up the files from the registries, will also help probably maintainers to not package the stuff that can be distributed through the registries, like all these Rust crates that only used at the build time simply to deliver the sources that then consumed in the build of Rust package. They can be in the private Fedora. Private means that Fedora owns it, not somebody else. But it's publicly available crates registry, which is still maintained in a similar way how we upload package content right now through Fedpkg and new sources and upload it there. But just publish it through the registries only. So it's kind of a possibility and maybe a way forward in solving this impasse that we have with the modern languages. So that's really what I have. And let me see if I get back here. So coming back to this vulnerability report that I made with vulnerability check. The report is actually uncovered like a dozen known CVE issues in the components that this new web UI depends on. So I filed a bug report upstream and attached the JSON file with the report. It contains references to things like a debug package, debug module that had some issues and needs to be updated and so on. In the ideal case, it should be made some tooling that can be can automate and convert those reports into human understandable actions or reasonable actions, saying please replace this package by this version, and here's what you get. Like it's your new package-log.json file that you can use instead of that one to populate your node modules local cache and see if your application is working with this combination of dependencies, because it might not be working. There might be some other issues and so on, but at least it increases the visibility of this problematic content, both to upstream developers and to the maintainers. And hopefully this will increase our security posture for Fedora as a whole. So that's really what I have, and we have like 3 minutes for additional questions. Yeah.
A bit of maybe philosophical question, like considering that we have some way of automatizing, of creating tarballs from references to those registries in a way that people say, hey, I want to bundle this and that tarball from, let's say, PyPI into a single RPM, and Koji does this automatically, downloads those zip files and creates a tarball for the RPM build. Aren't you afraid that people, the maintainers will be more disconnected from actually, manually reviewing those sources, and they will eventually stop doing that entirely, and we will mostly robotize the package maintenance, and these things are, the human factor in the packaging will be lost?
So I share your concerns about losing the human factor. I think that will happen anyway, judging by what is happening with different dist-git CI systems and things around. A lot of things will get automated. Maybe freeing that human resource from doing mundane work of updating to actually looking into what happens in their packages, getting closer to the analyzing what is they actually package, is a good thing. If we put this into the manual mode, nobody will be using it. But improving the automation and providing readable reports that can be actioned with some reasonable suggestions is probably what people need. Because otherwise, like we see this a lot with, for example, rebuilds from scratch, from source. When package fails to build from source, many maintainers are left puzzled because they don't know what's in there. right? Why this failure happened. So things like log detective, they are helpful because they help to find out actual problems why rebuild failed. But I'm trying to address a bit earlier problem, how we can handle the code, unsafe code that gets brought into the build environment or even in test environment, because the build environment is kind of isolated from network, but the test environment in most of the test CIs that we provide is not isolated from the setup there. And it's visible, for example, in things like GitHub Actions. GitHub Actions, people use GitHub Actions as servers that are accessible over internet by submitting pull requests to valid GitHub repositories and modifying GitHub Actions and run, for example, SSH server somewhere open in the world, because those tests have some validity time, like 6 hours or so for the GitHub. So you have open GitHub SSH server for 6 hours that you can use for whatever you want to get inside and attack the inside of that thing. So suppose somebody runs this as a part of a test, or sneaks something that runs as a part of the test, automated test within Fedora infrastructure. If it's on AWS, that's probably isolated and less visible to us. But if it's running within the Fedora data center, then that system has access to the internal thing, and it can be a command and control center for something worse. So preventing these kind of things before they even get built and then tested is important in my opinion. But we are past that time, and I don't want to hold you back from the lunchtime. Thank you.